The next section we're going to cover is imaginary numbers. So let's talk about number systems. What you've learned so far is in the real number system. Under the real numbers are rational numbers. Need a pen that works here. We have rational numbers and irrational numbers. But there's another number system called the complex number system. The complex number system also has imaginary numbers. Imaginary numbers are numbers under square roots. So, for example, we had negative 23, square root of negative 23 in the last section. That's imaginary numbers. At the bottom is a quote from your textbook talking about imaginary numbers. They were first used in 1637, and mathematicians couldn't understand in what sense that they would be used, and therefore the name imaginary came up, meaning that they couldn't imagine how they were going to use them. Later on, many years later, they realized that imaginary numbers can be very useful in the sciences. Flip to the next page. So what are we going to do? How are we going to solve imaginary numbers? So basically, instead of leaving the negative under the square root, we're going to take it out and call it I. So I is the square root of negative 1. If you square that, I squared, the square root of negative 1 times the square root of negative 1 is just negative 1. If we do that 3 times, the square root of negative 1 times the square root of negative 1 times the square root of negative 1, well, we know that 2 of them is negative 1, and 1 more of them is I, so we get negative I. So I to the fourth would be I squared times I squared, or negative 1 times negative 1, which is just 1. And I to the fifth would be I to the fourth times I, which is 1 times I, which is just I. And I to the sixth would be I to the fifth times I, which would be I squared, and I squared, as we did above, is negative 1. So you start to see the pattern. I, negative 1, negative I, 1, I, negative 1, etc. So the pattern for imaginary numbers keeps repeating after every 4 of them. So the pattern is I, 1, I, 1, the 2 in the middle are negative. So you can just count I to the first power, I to the second power, I to the third power, I to the fourth power, I to the fifth, sixth, seventh, eighth, 9, 10, 11, 12, and keep going. Okay, let's look at the next page. So let's look at simplifying. In the first example, let's just do I to the third power. Ignore this. So I to the third power. So let's go back. I to the third power. First power, second power, third power is negative I. So I to the third equals negative I. I to the fourth plus I to the fifth plus I to the sixth plus I to the seventh. Let's look at our pattern again. I, 1, the 2 in the middle are negative. So I to the fourth power is 1. I to the fifth power is I. I to the sixth power is negative 1. I to the seventh power is negative I. And no, that was the seventh power. So I to the fourth power, fifth power, sixth power, seventh power, as you notice, everything cancels and you get 0. Now let's look at I to the 98th power. You can count through 5, 6, 7, 8, 9, 10, 11, 12, etc. and keep going. But the easier way is just to think about that it repeats every 4 times. So if we took 98 and divided it by 4, we would get a remainder of 2. So that means we would go through the pattern 24 times, 1, 2, 3, 4, 1 time, 2 times, 3 times, 4 times, keep going, 24 times. And then we would go 2 more times, remainder of 2 means that we would get the I squared, which is -1. So let's look at I to the 1526th power. Okay, again we have our pattern. I1, the 2 in the middle are negative. So 1526, do the same thing. Divide by 4. You would again get a remainder of 2. So the 381 just means that we'd go through the pattern 381 times, and then we'd go 2 more numbers, 1, 2. So we'd get -1 again. Now let's look at negatives under radicals. So we can think of the square root of -4 as the square root of -1 times the square root of 4. Well, you know the square root of 4 is 2. The square root of -1 now is called I. So we get 2I. 5 plus the square root of -1. So we get 5 plus I. They can't be combined. Think of it, even though I is a number, think of it like variables that you can't combine. Square root of -12. Square root of -1 times the square root of 12. Square root of 12 is 4 and 3. So we get square root of 4, which is 2, square root of -1, which is I, and square root of 3. So basically, you're going to break down your radicals just like you did before, except if there's a negative, that means there's an I. So the square root of -7, okay, is I square root 7. And of course we have the negative on the outside, which stays as a negative on the outside. So don't confuse the negative under the radical with the negative on the outside of the radical. So very simple. You just have to remember the pattern I1, I1, and the 2 in the middle are negative. So pause the video, try the 4 problems listed there, and then we'll talk about graphing them, and we'll be done. Okay, so the 4 problems are listed here, or the work is done here. The first one, square root of -25 is 5i, square root of -4 is 2i, so 5i minus 2i is 3i. In the second one, we break down the square root of -28 to 2i square root of 7, and the square root of -7 to I square roots of 7. Combining your like terms, we get -4 plus I square root 7. Number 3, 7i minus 4i equals 3i. And the last one, 2i square roots of 5. 125 is 5 square roots of 5, so we change that -125 to 5i square root of 5. combining your like terms, you get 7i square roots of 5. Okay, and last page, we're going to just talk about graphing. You used to graph in the x and the y axis. The x-axis is still there, but now when we graph complex numbers, we're going to change the y-axis to the imaginary, or the I-axis. So if we have a number such as 2 plus 3i, just like before, we went over 2. Now instead of going up your y value, we go up 3 in the imaginaries. So over 2, up 3. The only difference here is obviously we have a plus instead of a point written, and we draw it as a vector. We'll talk about vectors later on. We draw it as a vector which has an arrow on the end. So how would you graph negative 5 plus 7i? So negative 5 to the left, 1, 2, 3, 4, 5, up 7, 1, 2, 3, 4, 5, 6, 7. There's your point. Go from the origin, draw a vector. How about negative 8 minus 2i? So go over negative 8, down 2, and lastly, let's go 7 minus 3i, and draw your vector. So that's it. You just have to remember your pattern. I1, the 2 in the middle are negative. And then graphing, just change your y-axis to your I-axis. And you're all set. See you next time.